Hey guys, I wanted to cover one of the 5 types of chemical reactions, and today I want to talk about the fourth one. It's called a double replacement reaction. And what a double replacement reaction entails is a chemical change involving an exchange of positive ions between two compounds. Okay, so we have two compounds right here. We have your AB and your CD. All right. Now, your AB has a positive and a negative, so does your CD. Now, initially, what happens is that your outside, your A and your D, and then your inside, your B and your C, form new compounds over here, the positive ion being first. So again, your outside, your A and your D, and then your inside, your C and your B form new compounds. That's essentially what a double replacement reaction entails when the equation works. There will be a continuation of double replacement reactions with something called net ionic equations, and you will be using a solubility table, but we're not doing that today. We're just learning how to uncrisscross and recross and reform the new compounds on the product side. So let's take a look. All right, so essentially, for a double replacement reaction to occur, one of the following is usually true. Okay, number one, which is one that we usually follow, okay, is that one of the products is only slightly soluble and precipitates to form a solution. Number two, doesn't happen often, but it does once in a while. One of the products will be a gas. And three, you can have one product will be a molecular compound such as water. So these are some of the cases that you could run into with these kinds of reactions. Okay, let's look at the first reaction here. As an example, we have Ki, which is potassium iodide plus lead 2 nitrate. Now what happens is your potassium breaks away from iodine bonding with nitrate over here. So your outside bonds, okay? And then your inside, lead iodide, form a new compound over here. So this is essentially what a double replacement reaction is. Then you go ahead and balance it. All right. So if we look at this one here, we can see that we have a solid that forms. All right. So in this equation, we can see that lead iodide forms this beautiful yellow solid in the beaker. And your potassium nitrate is still in the liquid form, okay? But that's something that we don't need to worry about at this moment in time. We're just learning how to crisscross them. So let's take a look at some examples on how to do that, and we'll break it down into your A, B, C, D, and form the charges for each one. Okay, now, here is the first example. So let me get color blue. Okay, so here we go. We have potassium carbonate plus barium chloride. So essentially what happens is that your outsides elements form the first compound over here. But what I like to do is, with you guys that are new, is write down what the ions are first. So you have to uncrisscross a little bit here to get the correct charges. So potassium gets the +1, okay, because that's what it has. CO3 as carbonate, that has a 2 minus. Okay, then your barium over here has your 2 plus, and your chlorine has the 1 minus. Okay, so let's put our elements together and form our new compounds over here. So for the first compound, it's going to be K and Cl. Okay, they both have a 1 charge. So therefore, if you crisscross, you get a 1-to-1 ratio. Okay, so the one goes there and the other one goes there, forming KCl. Very simple. Okay, remember, 1, 1, we don't write ones. Now for here, for the center, for your BaCO3, it's very simple. We start with our Ba, 2 plus, and our carbonate, 2 minus. Okay, now they have the same charge, but it doesn't matter. We crisscross them over, Ba, 2, CO3, 2, like so. And then you reduce both of these by 2, forming BaCO3. Okay, just like that. And we write that here, BaCO3. And that's it. That's as simple as it gets. And then we go ahead and balance it, and we plug in our numbers that we needed, a 2. And with that 2, that's all we have to do to balance it. We have 2 Ks on the left, 2 Ks on the right, 1 carbonate on the left, 1 carbonate on the right, 1 barium on the right, 1 barium on the left, 2 chlorines on the left, 2 chlorines on the right. Remember, this 2 goes to K and Cl. All right. Let's move to the next example. All right, so here we go. We have magnesium sulfate plus sodium fluoride. So what we're going to do is we're going to do the same thing we just did before. Okay, so your outsides will form new compounds and your inside. So write down the ions of what they are. Magnesium is a 2 plus. Sulfate is a 2 minus. Sodium is a 1 plus. And fluorine is a 1 minus. So over here, we're going to do our AD. So that's where it's going to be magnesium fluoride. 2 goes over there. We crisscross. 1 goes over there. So it's going to be MgF2. Let me write that here. And then over here, we have our CD, which is Na plus SO4 2 minus. Oops, 2 minus. We crisscross. The 1 goes over there, and the 2 goes over there. So it's Na2SO4. Na2SO4. Simple as that. And then we go ahead and balance it. So we got to put a 2 right here. Okay, so we have 1 magnesium on the left, 1 magnesium on the right, 1 sulfate on the left, 1 sulfate on the right, 2 sodiums on the left, 2 sodiums on the right, 2 fluorines on the left, 2 fluorines on the right. Looks good to me. All right, so now for the next example, let's look here. We have, all right. We have calcium phosphate plus ammonium nitrate. Okay, so once again, we're going to do our outside, inside. Outside and inside. So we're going to write down our ions. Like so. Now, I want you guys to pause the video, crisscross the appropriate compounds to get your ADCB. Try that on your own, then check with me my answers when you're done. Pause the video now. All right, so what you should have for your final answer, let's see, we have our AD, which would be calcium 2 plus, and nitrate. 2 goes over there, and the 1 goes over there, forming CaNO3 2. So that's our AD. Like so. And our CB is NH4 plus, and our phosphate, okay, 3 minus. The 1 goes over there, and the 3 goes over there. So it's NH4 3 PO4. So that's your final compound. That's your CB. And then from this point, you just simply have to go in balance. Okay? So what you do is you have to put a 6 there, 3 there, and a 2 there. And that's it. Okay, so we have 3 calciums on the left, 3 calciums on the right, 2 phosphates on the left, 2 phosphates on the right, 6 ammoniums on the left, 6 ammoniums on the right. 3 times 2 is 6. All right. 1 nitrate on the left. I'm sorry, 6 nitrates on the left and 6 nitrates on the right. 2 times 3. And that's it, guys. That's double replacement reactions. They all follow the same format. You do not have to do this portion if you don't want to. You don't need to do it. It's just a good way to see how these reactions form. I recommend doing it in order to get the appropriate, correct answer the first time without making any kind of mistakes. Okay, but if you can see it uncrisscross and recrisscross in your head, that's fine. I do it without doing this, but it does take time. I've been doing this a lot longer. All right, guys, have a good day.